Okay, so start tayo dito sa lecture na to. We have stresses in beams. Okay. Basically, we will talk about what we call the flexural stress formula or flexural stress. Yan. And flexural stress or the stress due to bending, let's say it's F sub B, the stress due to bending is actually equal to my over I, where m is the applied moment. So, yung m, yan yung moment. I is what we call the moment of inertia of the section. Moment of inertia. Tapos, yung y, this is a distance. Okay, distance from the neutral axis. Now, if I have a rectangular beam, okay, rectangular beam, the neutral axis is the axis passing through the centroid of the rectangular beam. So, kung ito yung centroid, since sa rectangle yan, nasa gitna yung centroid, ito, this axis shall be called as the neutral axis. Now, the moment of inertia is referred to this neutral axis, pati yung y referred din sa neutral axis na yan. So, for example, if I have a point here, let's say point, this is a fiber A, and this is the distance from the neutral axis. Ito yung y doon sa formula natin. Okay? Now, if you observe, relatively constant yung moment na sa isang section, yung I that is based on the shape, yung y lang nag-change dito. Depende kung saang point yung kinukuhanan mo ng flexural stress. And if you put yung y mo sa pinakamalayo na lugar, or we call it the most extreme fiber, either in the top or the bottom. So this, we label it as letter C, at yung makukuha mong flexural stress dyan would be the maximum. Now, sometimes, we have this formula, I over C is equal to S, where S is what we call the section modulus. Okay, section modulus. Now, yung section modulus, it is a property of the section based doon sa shape niya. Now, pag titignan mo yung flexural formula, ang sinasabi lang nito, diba, ang maximum bending natin would be MC over I. Now, kung papalitan mo to ng S, this would be equal to M over S. So, yung maximum bending natin, yung max, let's label it as a max para hindi tayo ma-confuse. The maximum flexural stress or bending stress is M over S, where S is the section modulus. Now, ano ba yung section modulus? Ano ba yung moment of inertia na yan? For rectangular sections, so let's have here a rectangle. Okay, for rectangular sections, let's say this is B, the base is B, and the height of the section is, or the depth of the section is D. Okay, or H na lang, height. H na lang, sabi natin H for height. Now, the moment of inertia at the centroid, with reference sa centroid or the neutral axis, this is equal to 1 over 12 base times height cube. Now, yung C, kapag rectangular section, yung C sa bottom at C sa top, that would be equal. So, it doesn't matter kung fiber sa top o sa bottom kukunin mo. Yung C nito, this is H over 2. It follows na yung S is I over C, which is 1 over 12 times BH cube over H over 2. And this simplifies to, let's see, 12 sa baba, H, paano? I think this is BH squared over 6. Okay, so it's BH squared over 6. Ito yung section modulus for a rectangular section. Okay, now, marami pang shapes bukod dyan. Okay? Marami pang shapes. So, for example, let's have a circular shape. Okay? A circular shape with diameter D or radius R. So, R or, sige, R na lang. Okay? Or depende kung saan ka sanay. Ako kasi sanay ako sa D, diameter. So, diameter is D. Okay? Now, we have this circle, and the moment of inertia for a circle is pi d cube over 64. It's 1/4 raised to 4. So the I is pi d raised to 4 over 64, or pi r raised to 4 over 4. I think this is 64. Let me check. 16 times 6 is 64. Yes, okay. So, yan. Now, yung section modulus niyan, magiging, of course, kung ito ang neutral axis mo, the extreme fiber will be at a distance r. So, if in terms of the radius, this would be pi r4 over 4 divided by the extreme fiber r. So, this becomes pi r cube over 4. Now, in terms of the diameter naman, the section modulus is pi d raised to 4 over 64. Divide it by, okay, in terms of d tayo, so r is, siyempre, itong maximum distance na to, d over 2 yan. So, divided by d over 2, we have pi d cube over 32. So, for circles, ganyan siya. Now, let's have another shape. So, basic review lang to ng moment of inertia ng mga basic shapes. So, now we have triangle. Okay. Let's have the height of the triangle as h. So, gamit tayo ibang kulay sa mga dimensions. Okay. And let's have the base of the triangle. Yan. Equal to B. Now, saan ba nag-o-occur ang centroid ng triangle? Nag-o-occur yon at this point. Okay? At that point, approximately, ito ay may distance na 1/3 of h. So, that's h over 3. And of course, yung fiber niya sa top, hindi na siya nasa gitna ngayon. Yung top fiber niya will be in a distance of 2/3 of h. So, let's write it here. This is 2/3 of h, this distance here. So, ngayon, derive natin yung section modulus niyan. We have the centroidal moment of inertia of a triangle. If you can still remember from statics, that's 1 over 36 BH cube. Okay, 1 over 36 BH cube. Ngayon, pag kinukuha natin yung S, we are referring to the maximum. So, ito yung maximum distance from the center, maximum, yung pinakamalayong fiber niya, which is 2/3 h. So, let us continue. The section modulus, therefore, is I over C. Ito yung C natin. So, this becomes 1 over 36 of BH cube over 2/3 of H. And so, this is equal to BH squared over 36, 24. So, ito ang moment of, ito ang section modulus ng triangle. So, ganun lang pagkuha ng section modulus. Okay, so, on the next lesson, we will try to answer problems regarding the flexural stress. We will use these formulas. And particularly, we will make use of of this formula, flexural stress formula. So see you on the next lesson. Okay, so this is example number 1 for our lecture. For the beam shown, we need to compute the magnitude and location of the maximum flexural stress and determine the type and magnitude of the stress in a fiber 40 millimeters from the top of the beam at a section 3 meters from the pre-end. So we have two questions here. Number 1, kailangan natin makuha yung maximum flexural stress. And para makuha yon, of course, since we are maximizing things, kailangan mo dyan yung maximum moment. So, let's say, max na lang yun, yung maximum moment. Saka yung maximum Y mo. Yung Y max, of course, yan yung C. And since this is a rectangular section, it doesn't matter kung top o bottom. Okay? And determine the type. So, ito yung pangalawa mong tanong. Type and magnitude. So, importante to. Type and magnitude. Teka, hindi ko ini-erase yung words, no? In-underline ko. So, yusin natin the type and magnitude of the stresses in a fiber 40 mm from the top of the beam at a section 3 meters from the pre-end. So, kung ito yung pre-end, dito yung 3 meters na point, dito, okay, dyan yung 3 meter point. So, kukunin mo yung moment at 3 meters. Dito yon. From the pre-end. Ito yung pre-end. Okay? Pre-end. Tapos, 40 millimeters from the top of the beam. So, yung fiber natin, okay, kung ito yung neutral axis mo, yung fiber natin, okay, this must be 40 millimeters from the top. So, kung nasa gitna ang neutral axis mo, 200 yung total height, syempre, 100 to. Diba? 100. Kung 100 yan at 40 yon, ang distance nito from the neutral axis should be, obviously, this should be 60 millimeters. So, ayan. Simulan na nating isolve to. Ang una natin kailangan gawin, hanapin yung maximum moment. Of course, for cantilever beams, the maximum moment will occur dito sa dulo niya. Okay? So, kunin natin by taking the right side of the beam and summing up moments, malalaman mo that the maximum moment will most probably act in a general direction na ganito. Okay, that is a clockwise direction. So, it's a negative moment. Okay? So, solve natin, no? The maximum moment, this should be equal to negative times the resultant of the triangular load. Okay? The resultant of the triangular load is, lagyan natin yung ganitong brace dyan. So, it's a bracket. It's 1/2 times the base of the triangular load, 6 meters, times 1,000. Okay? Ito ang resultant ng triangular load times a moment arm. Ano yung moment arm natin? Moment arm, since it's a resultant of the triangular load, dito mag-a-act yun at 1/3 nitong 6 meters. So, at 1/3 of 6 meters. Okay? So, hindi na pala kailangan tong grouping symbol na to. Yan. Okay. Now, if you compute that, you will find out that it is, okay, yan. Naglabas ako ng calcu para mas madalian ako. So, 1/2 ng 6, negative 1/2 times 6 times 1,000 times 1/3 ng 6. Ito yung moment arm natin. So, this is equal to negative 6,000. So, the maximum moment is negative 6,000 Newton meter. Okay, newtons lahat yan sa meter. So, Newton meter yung ano ko, units ko. Now, what is Y max? Of course, that is C. 100 yon. Since 200 to, yung C mo, okay, this is 100 millimeters. Okay, importante yung mga units niyan. Mamaya titingnan natin. Okay, so to find the maximum bending stress, okay, maximum, we need MC, syempre maximum moment, times C over I. Meron na tayo nito, meron na tayo nito. So, kailangan natin si I. Yung I, this is BH cube over 12. So, balikan natin yung figure. Ano yung B? Okay, B is 60. H is 200. So, substitute lang natin dito yung values. I is okay, 60 millimeters times 200 cube over 12. So, we get I equal to, again, tingnan natin sa calculator. This is, okay, 60 times 200 cube over 12. So, yan. Press mo lang to for engineering notation. So, that's 40 times 10 raised to 6. Okay? 40 times 10 raised to 6 millimeter raised to 4. Okay? So, kompleto na natin tong mga kailangan sa formula. No? By direct substitution, okay? By direct substitution, F sub B max, the maximum bending stress or flexural stress is 6,000 Newton meter. So, negative 6,000 Newton meter. Now, mapapansin mo, yung C mo naka-millimeters, yung I mo naka-millimeters din. So, gawin natin tong millimeters. We need to convert this. Okay? Convert it to millimeters. So, 1 meter is equal to 1,000 millimeters. So, para makancel yung meters, magiging millimeters na siya. Tama ba tong natin? Oh, sorry. Baliktad pala, baliktad. Okay, baliktad. So, easy tayo sa conversion, ha? 1,000 millimeters. 1 meter, baliktad. Para denominator to, numerator, nakakancel siya. Okay, so millimeter na yung moment natin. Okay. So, i-move lang natin konti itong okay. Move natin kasi masikip na yung side na yan. Okay, yan. So, yan. Times C. Yung C natin is 100 millimeters. Okay, divided by I, which is 40 times 10 raised to 6 millimeters raised to 4. Okay, so FB max, yung maximum bending stress mo ngayon ay equal sa sasabihin ng calculator. So, substitute mo dito. I-type mo lang dito, 6,000 times 1,000 times 100 over 40 times 10 raised to 6. Okay, so 15. So, the answer is 15 Newton per, okay, ilang millimeter yan? 2 millimeter, cancel. So, per millimeter squared or 15 megapascal. So, yung megapascal, yan yung Newton per millimeter squared. So, masanay na kayo na Newton at millimeter para megapascal lagi yung lumalabas. Okay? Okay, balikan natin yung tanong. Tapos na tayo dito sa maximum flexural stress. We have determined that it is 15 megapascal. By the way, baka may question kayo, bakit wala na yung negative? We are not really, considering muna yung negative because we are not being asked about the type. And remember, anyway, kung nilagay mo yung negative, magiging negative yung sagot. Anyway, yung C kasi natin, this can be a positive or negative depending kung upward or downward sa neutral axis. And since maximum yung hinahanap sa rectangle, parehas lang yung C sa taas at baba. So, this will not matter for this problem. But for the second one, tinatanong yung type. Now, ano yung type nung stress na to? Ano yung type na sinasabi dito? Ito yung kung either compression siya o tension. Okay? So, for this beam, yung maximum stress niya, magbe-bend yung beam ko pa ganun. Okay? So, pag tinignan mo yung fibers dun sa dulo, kung ito yung support, okay? Ito yung beam mo, magbe-bend siya pababa. Ganyan. So, mako-compress itong side na to, tutulak dito. Tapos, hahatak naman dito sa taas na part. So we know na tension stress dito sa taas at compression stress sa baba. All throughout sa cantilever beams, ganun. Tension stresses sa taas at compression stresses sa baba. And we will find out na ganun nga mamaya. Okay? So, yan. Sagutan natin yung pangalawang problem. Ito, 40 mm from the top of the beam at a section 3 mm. So, kailangan mo dyan, unang-una, yung moment at 3 meters pala, not mm, but meters. So, at 3 meters. So, pag kinat mo siya dito, okay, ang makikita mo, so, ito yung original mong beam. May triangular load ako na, ilan yun? That's 1,000, diba? 1,000 Newton per meter. Ang distance nito ay 6 meters. So, by ratio and proportion, pag kinat ko siya at 3 meters, okay, by ratio and proportion, 3 meters to, yung magiging magnitude ng load ko dito sa kabilang end, this will be 500 newtons per meter. And that is obvious kasi kalahati ng 6,3. Of course, makakalahati din yung triangular load dito. So, kalahati ng 1,500. So, ito siya. Kinat ko siya ngayon. Merong ma-expose yung shear sa moment. We are only interested dito sa moment na part. Okay? So, kunin natin tong moment niya. Okay? By summing up moments, we can see that the moment is equal to, okay, equal to ilan? We have a triangular load. So again, that's 1/2 times base, 3 meters, a height of 500 Newton per meter, times a moment arm. Yung resultant niya nandito. So ito will be 3/3, 1 meter. 1 meter yung magiging moment arm. So 1/3 of 3. So 1 meter ang moment arm. So the moment is, again, let's use our calculator. Okay, so 1/2 times 3 times 500 times 1. Kahit wala na yung times 1. Okay, so ang moment niya ay 750 Newton meter. Okay, sulat natin dito. 750 ang units, cancel to. So, Newton meter. Okay. So, ano pang kailangan natin? Yung beam natin ay may section na. Drawing lang natin ulit dito. Yung kailangan mo it's 60 millimeters above the neutral axis. By the way, ang I nung beam natin kanina, 40 times 10 raised to 6 millimeters raised to 4. Okay, so kompleto na yan. Actually, pwede mo nang gamitin yung ano natin, yung formula natin for flexure stress. And yung formula na yon, remember, that's F sub B equals my over I. Okay? So, M, 750 Newton meter times, convert mo ng millimeter, since millimeter yung Y, saka yung I. This is 1,000 millimeters is to 1 meter. Okay? Times Y, which is 60 millimeters, divided by I, 40 times 10 raised to 6 millimeters raised to 4. So, yung stress at 3 meters, yan ay equal to 1.125. So, using your calculators, you should be able to get 1.125 megapascal. At since nasa top fiber siya, this would be in tension. Okay? Top fiber ng cantilever beam. So, just use your imagination. Of course, kung nasa top fiber siya, in tension yan. Okay? Now, kung gusto mong mas stricto, gagawin mo ganito. Yung Y mo, ito ang positive. Tapos, yung moment mo, let's be strict. This is a negative moment. Kasi, binibend mo yung beam mo na naka-sad face. Diba? Pa ganyan. So, it's a sad bending. So, negative moment to. So, negative yung moment. Pababa yung positive mo sa Y. So, this should be negative 60. Negative and negative. Positive and tension positive tayo. So, yan. Ito ang sagot natin for the second question.